Hey again, everybody. I'm going to go ahead and work through this next problem. I think on the actual original assignment that I gave you, I had put this in as 7A. Apparently, it went from 5 straight to 7. I have an inversion to 6. So if you're looking at this, please don't be too confused. I went and relabeled things so that I actually have a 6. So be it. So here's where we are. This is the problem that I'd like to look at with you here. And it reads as follows. I'm actually going to grab my highlighter here just so I can highlight things that might be of use to us as I read for this process. This one says, during a softball game, a player running from second base to third base reaches a speed of 4.5 meters per second. Aha. They start to slide into third base. By the time they reach third base, 1.3 seconds after beginning the slide, their speed has reduced to zero point 0.6 meters per second. What is the player's acceleration during the slide? There's a lot going on here, and there's extra information. Often physics problems have to kind of explain a story, and some of that story is not tremendously useful to us in order to solve the problem. Like the idea that they're running from second to third base. Okay, it gives us the story, but it doesn't help us to solve the problem necessarily. So we have to figure out what is useful to us and what's not. I'm going to go and highlight one last piece here to this so that I don't lose it and say, what is the player's acceleration, right? These are the things that I know versus the thing that I kind of want here. I can once again go back here and annotate this if I want to, and giving these things actual things. So it says they're reaching the speed of this before they start to slide. So this kind of piece right here, this 4.5, is a velocity. And we could say that this is my kind of starting velocity. So I might say that this is VI. This is my starting velocity. On the other hand, it says by the time they reach the third base, and then they give a certain amount of time later. So this is a certain amount of time. So this is a change in time that's happened, right, as we go. And this last piece that's down here is the 0.6 is in meters per second. So that is my final velocity here. So VF, right? It used to be 4.5 and now it's 0.6. So we've slowed down. So there's an acceleration. And I know that acceleration is negative because we've slowed down. So a few things to think about. And last, let's go ahead and put in a letter for this one. So this is my annotation of the problem. I've highlighted the things. I've wrote down some variables, and off I go for this. So if I want to, I could go ahead and say, here's my problem. This is my base over here, and then there's another base that's over here. And let's say that this person is sliding, and let's say that they are sliding like head first towards the base over there. They're like, yeah, they're in it. So here's the baseball cap that we're wearing there, and we're sliding towards the second base from third base. So this is kind of the second base here, and this is the third base over here. So these are the pieces that we're looking for, and I'm going to go ahead and plug in the rest of the puzzle to make things happen. I've got, again, I'm using my deguess. So my deguess puts me in here where here's my drawing. That's my starting point. So the next piece to this puzzle is the writing down my knowns, or my givens, I guess is a better way to say that. Excuse me. So my givens, the things that I already know. Now I actually have them up here, but I'm going to label them down here as well, just to make sure that I know what I'm talking about. So I'm going to go ahead and say that my starting velocity, which is VI, is equal to 4.5 meters per second. My final velocity is something else that I know, right? And my final velocity is 0.6 meters per second. So I've got a starting and a final velocity. I also have this amount of time that was given. So it's a change in time here, and that change in time is given at 1.3 seconds. So far, things are looking pretty good. All of my units of length are in meters, and all of my units of time are in seconds. So I don't think I'm going to have to do any converting on this problem, which saves me some time within the process. So I've got a D for my drawing, I've got a G for my givens, and now I've got my unknown, right? And my unknown, I have that one as well. That's my acceleration up here. So I'm going to just drop in an A equals question mark. And now we're at the point where I need to put in my equation, to guess, right? So what equation do I need? I need an equation that involves velocities, times, and accelerations. And because I'm not interested in changes in position at all, the only equation that I've got that has nothing to do with changes in position is this equation here that is A equals delta V over delta T. Now, do I have a delta V? I kind of do because I've got a starting velocity and an ending velocity here, or an initial velocity and a final velocity. So I do have a change in velocity that's happening, right? It's not written up here, but I know that I've got it here. And it turns out that I'm actually already solved for acceleration, so I don't even have to algebraically rework this problem. It's turning out great. So I've got a dGUE, and now I need to substitute. But I do want to write one more thing down here because I don't have all of my kind of variables that are here shown. So I'm going to go ahead and write this delta V, right, using these kind of V's here, where whenever we do a change in velocity, we take our final velocity, which is VF, and I subtract to my initial velocity, VI. That's what a change in velocity really means if you were to write it out. Final minus initial, that's the way we do changes in. And then on the bottom, I'm just going to keep it as delta T. So I haven't done anything different here other than the fact that I've broken down this into the two variables that I happen to have up above. So now I'm ready to go ahead and substitute so that I can solve. So I've got now A equals, and I'm going to substitute in for my final and initial velocities and time. So my final velocity is the 0.6, so 0.6 meters per second. That's my final velocity. And I'm going to subtract from that my initial velocity, which is 4.5 meters per second. So I'm going to subtract from that. And then on the bottom, I'm going to go ahead and divide this by my change in time, which is 1.3 seconds. So good so far. Now I need to continue because I've substituted. So now I'm going to go ahead and solve this one. And I'm just going to write it here because I'm running out of room down below. So I'm going to start solving this. So I've got 0.6 and I'm going to subtract 4.5. 0.6 minus 4.5. If this was 0.5, 4.5, then I would be at -4, but I'm at 0.6. So I'm going to end up with a negative, what? Negative 4.1. Is that right? I think so. Meters per second. If I was to add 4.1 to this, I would end up with that. Yeah, that seems okay. And my time now, I'm going to use this on my calculator, making sure that I've got this right. So I'm going to divide that by 1.3 seconds, making sure that I've got 0.6 minus 4.5. Minus 4.5. Oh, I did it the wrong way around. This is what you get for doing mental math and not being fully awake. So negative 3.9. It didn't look right when I was doing, which is why I was hesitating. And it's always a good idea to check with a calculator along the way. So if you got that, you are on it, and I love it. But that's kind of our piece here is negative 3.9. All right, so if I take this negative 3.9 and I divide that negative 3.9, so negative 3.9 divided by 1.3, well, this is nice. This comes out pretty, right? It comes out as negative 3. That's outstanding. Look at that. So 3.9 divided by 1.3 comes out as negative 3. And if I take meters per second and I divide by seconds, I'm getting an acceleration in the end. And my units for acceleration, thankfully, are meters per second squared. And that's what happens if I take meters per second and I divide by seconds, I get meters per second squared. So this is my final answer here after I've solved. It asked me what is my acceleration, and my acceleration is a negative 3 meters per second squared. That's how we do it. And the negative just here just means I'm slowing down. Hopefully that's helpful. I'm going to go ahead and take a look at 6B, which I think on your paper is like 7B, but go with me here and we'll go from that. All right, so I'm going to stop this video and then I'll take a look at the next one.